Today, I've got an interesting problem for you. Here we have a square, and inside it, there's a point P. The distances from this point P to the three vertices are 1, 2, and 3, respectively. Now, let's find the area of the square. To visualize this problem, I've drawn three concentric circles with radii 1, 2, and 3. Then, I've drawn a square to fit the given situation. The diagram is complete. Now, let's calculate the area. For the first step, I'll draw a triangle congruent to triangle ABP, and then rotate it to attach to side BC. This helps us find that CE has a length of 1 and BE has a length of 2. Now, let's examine the angles. If we denote angle ABP as alpha, then angle CBE is also alpha. And let's call angle PBC as beta. The sum of alpha and beta is 90 degrees, making angle PBE a right angle. Since both sides PB and BE have length of 2, triangle PBE is a right isosceles triangle. And we can determine that PE has a length of 2 square root of 2, which can also confirmed using the Pythagorean theorem. Next, let's consider triangle PEC. We know the length of all three sides, so we can determine all the information about triangle PEC. From this, we conclude that angle PEC is 90 degrees, again easily confirmed using the Pythagorean theorem. Now, let's extend side CE and draw a perpendicular from point B to line CE. This reveals that angle BEF is 45 degrees, making triangle BFE another right isosceles triangle. And we find that BF and FE both have length of square root of 2. In the final step, let's look at triangle BFC. If we denote the length of BC as K, then the area of the square will be K squared. Now, with BF as square root of 2 and CF as square root of 2 plus 1, and as triangle BFC is a right triangle, we can apply the Pythagorean theorem again. This leads us to the conclusion that the area of the square, K squared, is equal to square root of 2 squared plus square root of 2 plus 1 squared. Upon calculation, we get 5 plus 2 square root of 2, which is our final answer. Have you found the correct answer? Good job! I'll bring more interesting problems for you next time again.